Greetings everybody, and welcome to Euclid's Proposition number 7. In this proposition, we are given two straight lines constructed on a third straight line from its extremities, and we're told that these two straight lines meet at a point. Furthermore, we're told that it is impossible to construct on the same straight line from its extremities and on the same side as the two lines that we have two other straight lines which are going to be congruent respectively to those two lines and which meet in some other point. Now, that's kind of a lot to understand just from words, so let's see if we can draw a picture and see if we can make a little more sense of this. So basically what this proposition is saying is that if we are given a straight line segment, AB, and we're given two other line segments from the extremities of that one, then we are told that it will be impossible to construct another set of straight lines, also from the extremities, meeting at some other point, such that we have a congruence between our line segment AC and our line segment AD and our line segment BC and our line segment BD. So we're actually told that this is going to be an impossible picture. As long as C is not equal to D. All right, let's see if we can go about proving this particular proposition. So in this particular proposition, we're going to do a proof by contradiction. And so what we're going to actually assume is that we can draw this picture. So if we can draw this picture, then let's deduce some properties from it. So we're told that our line segment AC is going to be congruent to our line segment AD. And we're told that our line segment BC is going to be congruent to our line segment BD. Well, what we want to then do is to add a new line segment, which from postulate 1 says we can connect any two points with a straight line, so we want to add our line segment CD. And so in drawing line segment CD, we then have that triangle ACD is going to be isosceles. Then from our proposition 5, which we've already proven, we then have that our angle ACD is going to be congruent to our angle ADC. And likewise, proposition 5 tells us that because our triangle BCD is also going to be isosceles, that our angle BCD and our angle BCD and our angle BDC will also be congruent. Now, at this point, we can do some angular arithmetic. And what we mean by that is that we take a look at our angle ACD. And we see that that angle ACD is actually made up of two other angles. It's made up of our angle BCD and our angle ACB. So because our angle ACD is made up of two other angles, in particular, this means that our angle ACD has to be larger than our angle BCD. And kind of doing the same thing with our other two angles, we know that our angle BDC, we can see that one is also made up of two other angles. It's made up of our angle ADC, and it's made up of our angle ADB. And so in particular, it means that our angle BDC is going to be larger than our angle ADC. Okay, so now let's put all of our angle relations together. We have that our angle ACD is going to be the same as our angle ADC. And we have that our angle BCD is going to be equal to our angle BDC. And we have that our angle ACD is going to be larger than our angle BCD. And finally, we have that our angle BDC is going to be larger than our angle ADC. So now, because ACD is the same as ADC, we can make the replacement in this inequality and replace our angle ACD with our angle ADC. And likewise, because our angle BDC is the same as angle BCD, in our second inequality, we can replace our angle BCD, our angle BDC, with our angle BCD. And so we have angle BCD greater than our angle ADC. And in doing this little arithmetic, we now have our contradiction. We have shown that our angle ADC is going to be larger than our angle BCD, but then we've also shown that that exact same angle, our angle ADC, is going to be smaller than the same angle BCD. And so it's those two things together, one angle bigger than another angle, but that angle is also smaller than the same angle. This is what gives us our contradiction. That it's impossible for an angle to be both larger than another angle and smaller than that exact same angle. And so what this really means is that our initial assumption where we had that we could draw this picture with C not equal to D gives us this contradiction. And so if those two points are different, then we get a contradiction. And so what this really means is that it's really impossible for us to have that C is not equal to D. Therefore, so that we don't have contradictions, it has to be the case that our 2 points, C and D, are really the exact same point. And so that was where we wanted to go. I hope you guys have enjoyed this, and as was to be demonstrated, we have now done Euclid's Proposition 7. See you guys next time.